So last section of chapter 10 was circles. 10.5, we're going to be talking about secant lines, segments, and angles from those lines, okay? So we're going to talk about the three different lines that we know so far. Well, we know two, we're going to know three. So go ahead and draw a chord. Remember, a chord is the endpoints are on the circle. Okay, so this is a chord. The other line we know is tangent. What do we know about a tangent line? Touches one point on the edge, and what does it create? 90 degrees. Good. This last one we're going to talk about is a secant line. Okay, what a secant line does is it goes through the circle, but not through the center. Okay, so I'll write that definition for you. Secant line is a line that goes through the center. Nope, sorry, not through the center, through the circle, but not through the center. Okay, a line that goes through the circle, but not through the center. What I want you to understand with secant lines is, yes, they can sometimes go out of the circle both ways. Okay, that's also a secant line, but most of the secant lines we're going to see today are one endpoint's on the circle, and then the other side goes through. Okay, what do you notice about all three of these lines, the chord, tangent, and secant? None of them go through the center. What's the only line that goes through the center? The diameter, okay, and the radius is attached to the center. But none of these lines go through the center. Okay, again, reminder, chord is connected at the endpoints, tangents on the outside connecting at one point, and the secant goes through. Okay. Okay, this diagram is what you have on your example 1. Recap, what is angle 1 congruent to? Left, right, or up? It's the up one, right? What are those called? Vertical angles, okay? So those two are congruent to each other because they are across from the vertex from one another. And they're straight lines, that's why we can assume that. How would I find this angle measure right here if I knew what angle 1 was? Subtract it from 180 because they make up that straight line. So remember, whenever you see a straight line, think of 180 there. Okay, so that's a little recap. I'm going to highlight these arcs. What do you notice about these two arcs compared to angle 1? They're across from each other, okay, and they're across from 1. What I want you to understand, and I'm going to try and draw this on the recording so people know, is that this angle creates the two arcs. Does that make sense? Like, their endpoints of those arcs are created by that angle 1. Okay, so angle 1 is connected to those two arcs. So if we were ever looking for angle 1 and we were given the two arcs, we're going to take the average of those two arcs to find the angle on the inside. So what that means, measure of angle 1, I would write this formula down. Measure of angle 1 is we're going to take arc BC, I'm just going to refer it to this picture, plus arc AD and divide that by 2. We're taking the average to find the angle on the inside. So let's apply that to example 1 here. It says BC on your paper says it's 61. AD is 155. So we're just going to plug in what we know into the equation. Okay, so to find that measure of angle 1, we add the two arcs. So 61 plus 155, and we divide by 2. Okay, always do this numerator part first. So 61 plus 55 is 216. 216 divided by 2 gives you 108. So the measure of angle 1 here is 108, which we already said this is also 108. Okay, on your homework, yes, you find that, but then it wants to know what this angle is. How do we find that one? 180 minus 108 to give you that 72. Okay, so to find the angle on the inside of a circle with the two arcs, you're going to do the average of the two arcs. Okay. This right here is very similar to that half sheet that I gave you. Okay, make sure you're on the 10-11 side. Okay, there's a 10-11, 10-12. Make sure you're on the 10-11. It looks exactly like what I have up here. Okay, Don't get scared by there's 3 different cases, okay? Because what I want you to understand is all of these formulas are the same exact thing. They're just different pictures, okay? So on this first picture here, we have 2 secant lines, 2 lines that go through the circle, okay? If we want to find the measure of the angle outside the circle, okay, we're not going to do the average anymore. We're going to take the big arc minus the small arc divided by 2, okay? And that's what your formula says on that sheet. We're going to take the big arc minus the small arc, divide that by 2. Okay. Again, just like the other one with the inside, this angle on the outside is intercepting both of these arcs. So these arcs were created by that angle. Okay. On this case 2, we are dealing with, what's this line? We're dealing with a tangent and a secant. It's the same exact idea. Okay. Those 2 arcs create that, or that angle creates the 2 arcs. So you're going to take big arc minus little arc divided by 2. And then same thing for case 3, but this time we have 2 tangent lines, but it's the same idea. Okay. I taught this lesson when I student taught for Saxer, and I will never forget what a student said to remember this. Ready? So if you want to write this down, go for it. I'm going to refer to this angle right here. He could never remember how to solve for this, so he came up with the far arc, so the farthest one away from here. He called it FARC, minus the close arc, but he called it the near arc, so NARC, divided by 2. So he always said FARC minus NARC divided by 2. Use example 2 here. I'm going to give you some numbers to fill in. If I told you this was 168 and this was 52, find that missing angle on the outside. Okay. Here, so our angle that we're looking for is on the outside of the circle. So we're not taking the average anymore. How do I solve this? 168 minus 52 divided by 2. So do that top part first. What's 168 minus 52? 116 divided by 2 is 58. Okay, go ahead and try example 3, A and B on your own. Okay, on example A, I'll give you a little hint here. You might have to use the equation I provided you on example 1 and fill in what you know. All right, on example 3A, the formula I gave you, it's used to find this angle on the inside, yes? Okay, but this time we are looking for one of the missing arcs that it has. So we're still going to use that same formula. We're just going to plug it in like an algebra problem. Okay, so what would we normally do to find this arc here, or that angle here? What would we normally do? What would we normally do with these 2 arcs? We find the average, right? So we take 74 plus x divided by 2. That would give us this angle on the inside, so 107. That's what we would normally do to find that missing angle. But now, what I have set up here is an algebra problem. So we don't like fractions. How do I get rid of that 2? Multiply by 2 on both sides. That cancels this side out. So I have 74 plus x equals 214. And then my last step here, subtract 74. So I end up getting x equals 140. Okay. Someone had a question and said, well, if this angle right here is 107, can't I just assume this is 107? Why can I not assume that? It's not in the center, right? And then similar argument, someone says, can I just multiply that by 2? Why can I not do that? It's not on the edge, it's not inscribed. Okay, so we had to use that formula that I gave you at the beginning of usually finding the average, okay, and then plugging in what we know. Okay, what about part B? Is the angle that we're looking for on the inside or the outside? Outside. So we're not going to do the average, we're going to do the subtraction. But do I have everything I need to know? No, I'm missing this little arc on the inside. How do I find it? 152 plus 126 is 278. From there, 360 minus 278 is 82. Yes? Okay, so now that I have both arcs, how do I find this angle on the outside? Yep, take 152, it's big arc, minus 82, the smaller arc, and then divide that by 2. So 152 minus 82, 70, divided by 2 is 35. Okay. This is not in your notes, but I want to look at this as a little example here. So what we're going to be doing now is we've been looking for angle measures and arc measures, but now we're going to be looking for segment lengths. Okay, looking for segment lengths, which when we had tangent lines, let me draw it. You do not have to draw this. If I had a tangent line here, how would we normally find segments of tangent lines? We did Pythagorean theorem, right? With these, what are these two lines called right here? Chords, secants, or tangents? They're chords. Their endpoints are on the circle. Okay, what we kind of do is we think of these in parts. Okay, so this chord right here is made up of 4 and x, right? So what we're going to do with those is we're going to take 4 times x. And then we do the same thing for the other one. What is this chord made up of? 6 and 5. So I take 6 times 5. So then it turns into algebra. 4x equals 30. This one doesn't work out very nice, but divided by 4, I would get x equals 7.5. So you think of these kind of in parts. Okay. Take that information, and that is the same on your half sheet there. That's case 1. Okay. Go ahead and apply that same thing to example 4. So on this one here, we have 2 chords. Remember, we think of them as in parts. So what's this chord made up of, GK? Y and 10. So we take 10 times y. Set that equal to, what are the other chords parts? 15 and 7. So I take 15 times 7. So what is 15 times 7? 105. Last up. Divide by 10. Y equals 10.5. So this is the one we just talked about where we had 2 chords. Okay. On this one, what 2 lines are those? What kind are they? On this one, they're both secant, right? Because they both go through the circle. Here, this is where we take into account, we have some of it on the inside, we have some of it on the outside. Okay, so to set it up, what our formula says is we're going to take the outside. What's the outside part of that I have highlighted? What I mean by outside the circle. So it'd be n. So I take n times, now we're going to take the total of that secant line. What's the total of the secant line? How would I find that? M plus n. Yep, now we're comparing the outside compared to the total of its own segment. Now we do the same thing for the other side. What's the outside length of this segment? Q. And then what would the total length of that be? P plus Q. Okay, so now the reason that we're adding these, is that the question that you're having? Why we're adding now? The reason we're adding these is because we're comparing it to itself on that one side. We're comparing the segment to itself, but we are taking into account what we have on the outside of the circle. Okay, so that is if you have 2 secant lines. So here, what do I have on this diagram here? We have a tangent and a secant. How is a tangent different than a secant? It doesn't go through the circle. It's on the outside. So you see how we only have one piece of this tangent line? Okay. What we do, okay, I'm going to write this in words so you can remember. We're going to take that tangent line and we're going to square it. That helps us take into an account that here, what is created at this right here? That right angle, right? That was a really bad radius. But we create that right angle, so we know that we have to square this tangent side here to account for what's not on the inside. Okay, so then this secant here, we set it up the same way that we set these up. So what's the outside? Z, and then we want times the total, Z plus Y or Y plus Z. Yep. Okay. Example 5A. What kind of lines do we have here? Tangent and a secant. So if you're looking at your cases, we're going to use that case 3. What do we do with that tangent line to account for that right angle? We're going to square it. So we take 6 squared equals, how do we set up the secant line?
9 plus a.
Yep, and then multiply it by the outside. Yep, so we take the outside, and then we multiply that by its total length, which would be 9 plus a or a plus 9, either way. Right, now it just turned into algebra problem. So what's 6 squared? 36. What do I do with this a here? Yep, a times 9. 9a. A times a squared. Okay, so you have not seen this type of problem in a long time because you're in geometry now. But in algebra, what did you do if we had an a squared and an a in the same problem? Can't combine them. What's the big F word? Factor. Okay, we're going to have to end up factoring this because we have an a squared and an a in the same problem. This is awesome review for MAPS testing, okay, because I know you're going to have a problem like this. Okay, so when you have an a and an a squared in the same problem, you want to get it into factoring form. What that means is you want to get everything on one side. So what is not on the same side as these two right now? 36. How can I move it? So, yep, subtract 36 on both sides. Now I'm going to rewrite it in standard form. What that means is I'm going to go from a squared, and then I'm going to have plus 9a minus 36 equals, what's left if I took away 36 on this side? Nothing. I'm going to put 0 there for that placeholder. Okay. Now we're in factored form. Does anyone remember what you're looking for?
Just like the two numbers that add up.
Bingo. Yep. Factors of 36. So two numbers that multiply to get 36 and add up to 9. So let's start listing some factors. I'll get you started. If I take 6 times 6, that'll give me 36. But does that get me to get 9 somehow? No. 9 times 4. Will those two get me to 9 somehow? No.
12 and 3.
It is 12 and 3. Well, can these get me to 9 somehow? Yes. What do I have to change? I have to subtract 3. Okay, so if I multiplied these together, I would get negative 36. If I added those together, I would get 9. Okay, so those are the factors I'm picking. Once you have the factors chosen, you just rewrite them as their own component. So this turns into a minus 3 and a plus 12 equals 0. What we just did is we just took our factors, negative 3, plugged it in with a, and we took the 12 and plugged it in with a as their own separate components. Okay. A squared's gone because, good question, if I would FOIL this back out, it would get me back to that point there. So here, does anyone remember what to do from here? Yes, set them all separately by themselves. So I can take this, a minus 3, set that equal to 0. And then I can do the same thing for that a plus 12, set it equal to 0. Now, basic algebra, you know how to solve those. How do I solve the left side? Add 3. A equals 3. Subtract 12. A equals negative 12. So we have our solutions here. So now we have to decide which solution makes the most sense. Why 3? You're exactly right. Right. Is there a such thing as a negative distance or a negative length or a negative angle measure? No. So that's an automatic no. Okay. If you for some reason got both of them to be negative, which you wouldn't have happen, you would just put no solution. Okay. If you had both of them positive, you would go back to your picture and ask yourself which one makes the most sense. Okay. All right. Let's get some confidence back on this one. EC, what kind of lines are those? Chords. How do we find missing side lengths of chords? Multiply the two pieces, right? This one is made up of 4x. This side's made up of 8 times 5, which is 40. So we get 4x equals 40. Last step. Divide by 4, we get x equals 10. All right, let's take a look at this example here. This is your example 5 diagram. Okay, so here, I'm looking for this angle measure. Is that angle on the inside of the circle or the outside? Inside. So are we going to be subtracting or are we going to be finding the average? We're going to find the average because remember, think average is the one that's going to be in the middle. Okay, is that angle in the middle of the two arcs? Yes, so you're going to find the average. So take 86 plus 60 divided by 2. What's 86 plus 60? 146. Divided by 2, you get 73. Okay, so that's a good way to remember it. If it's on the inside, it's in the middle. Average is you're finding what's in the middle. Okay? Okay, recap. If this was 73 and your homework, if it asked for this, 180 minus 73. Yes. Okay. Next one I want to do with you is number 6. Yes, hold that thought there. So we're looking for this angle now. Is that angle on the inside or the outside of the circle? It's outside the circle, right? Here's our circle. It's on the outside. Nathan, what'd you say?
I said subtract it from 360.
Right, because we want to know this arc measure. So we know it all adds up to 360. So take 360 minus 125, which is 235. So this arc measure is 235. Since the angle is on the outside, how do we find that missing angle? Are we finding the average anymore? No, what are we going to do? Yep, subtract big arc, 235, minus small arc, 125, divide by 2. What's 235 divided by, 235 minus 125? 110 divided by 2, 55. On number 7, now we're looking for missing side lengths or missing segments. What kind of lines do we have here? We have a secant and a tangent, okay? On this tangent line, do I care about this side? No, I don't. Okay, so they're just talking about this length right here is 12. So remember, if we have a tangent line and a secant, what do I have to do with that tangent line to account for that right angle? I have to square it. Yep, so take 12 squared equals, how do we set up the secant side? Close. We want to account for the outside. So the outside piece is 8. What I mean by outside the circle. And then multiply that by the total. Total of this would be x plus 8. And then algebra, what's 12 squared? 144. What do I do with this 8 here? Distribute 8 times x. 8x, 8 times 8. 64. Next. Subtract 64. So we get 80 equals 8x. Next. Divide. We get x equals 10. Okay, so the only time you square is if you have that tangent line. Only if you have the tangent line. So on number 8, what kind of lines do we have? They're both secant. So remember to set up the secant, we take the out. I'm going to do this one first. I'm going to take the outside, which is 7, multiply it by its total. What's the total there? 9 plus 7, yep, which is 16. Okay. And then do the same thing for this side. What's the outside of that secant line? 6. And then take that times its total. Yep. Okay. So here, do not distribute this 7. Order of operations tells you parentheses first. So what's 7 plus 9? 16. 16 times 7, I believe, is 112. And then this 6, what's happening? Yep, distribute. So we get 6x plus 36 there. And now we solve. Subtract 36.
Wait, why did you distribute the second one?
Not the first one. Good question. So order of operations, remember, is PEMDAS.
Yeah.
What does that P stand for? Parentheses. So here, could I simplify 7 plus 9?
Yeah.
Yeah, that's where we got 16. But over here, can I simplify x plus 6? Does that make sense?
Yeah.
That's why we had to distribute on that side. Okay. If I subtract those, you get 76.
Yeah.
This one doesn't work out nicely, if that's what you're wondering about.
4.7.
Yep. If it doesn't work out nice, just round to the nearest tenth like we have been. Divide by 6 here, so we get x equals 12.7.